So this is the first video of Chapter 3 of Unit 3, which is 3.1 Congruent Triangles. Okay, so I've drawn two triangles here, and I know that triangles are congruent if one fits perfectly on top of the other. Okay, we know that. We know that when two things are congruent, they are perfect. So this way, two triangles are congruent if one fits on top of the other, or if they coincide. Okay? All right, we say that these two triangles, ABC and DEF, are congruent. This is how we write when triangles are congruent. We put a triangle in front to say we're talking about a triangle, since we're not talking about the angle, and we put the congruent symbol in between. So we say that triangle ABC is congruent to DEF if 6 things are true. First, if angle A is congruent to angle D. If angle B is congruent to angle E. If angle C is congruent to angle F. The reason why we write it in this order here is this tells us that A and D have a relationship, B and E have a relationship, and C and F have a relationship. Along with just the angles, we also have to say that certain segments are congruent. So this tells me that segment AB is congruent to segment DE. Segment BC is congruent to segment EF. And then last we have segment AC being congruent to segment DF. So again, it's very important how we write it because AB has a relationship to DE, BC has a relationship to EF, and then AC has a relationship to DF. So these 6 things are very, very, very important. Writing this statement tells us all 6 of these things. So two triangles are congruent if the 6 parts of the first triangle are congruent to the 6 parts of the second triangle. So this is also true backwards. Okay, so that means that if two triangles are congruent, then the 6 parts are going to be congruent, right? Because if the 6 parts are congruent, then the two triangles are congruent. Okay, so the 6 pieces to remember are these 6 right here. Okay, so we have 5 methods of proving two triangles to be congruent, or 3 or 4 or whatever we need, right? So we have these 5: side, 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 angle, 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 side, and hypotenuse, leg. So we'll go through each of these. So when we talk about angles that are in between, okay, so we have 2 sides that form an angle between them. Okay, so I have 2 sides. So example, I have these 2 here. They form an angle between them. They're said to include the angle. Okay, so 2 angles of a common triangle. So for example, I have a triangle. I have this angle and this angle. Are said to include the side. So that means that this side is being included if I'm looking at this angle and this angle. This side and this side include this angle here. Okay, so if we use that idea, so let's see, if I draw a triangle here, I have TUV. So segment TU and UV include angle U. And you can actually see that right here, because see how it's the vertex? Both of them include that. We also know that angle U and angle V include segment UV. And you can see that UV, UV, TU, UV includes U, okay? So I drew my two triangles here. Side, side, side is just like what it sounds like. I have a side congruent to this side congruent to this side, and this side congruent to this side. So if three sides of one triangle are congruent, I'm using shorthand here, to three sides of another triangle, then the triangles are congruent. Now remember, it's very important how we write this. So I know that if AB is congruent to DE, I have to start with that. So triangle ABC is congruent to triangle DEF. And the reason would be side, side, side. We write that with 3 S's. Okay, for side, angle, side, it's just like what it sounds like. Now, first we need to talk about what it means to have an angle that's in between. So now if we look at this, okay, we can think about side, angle, side, angle, and side, okay? So that means I need to have at least I need to have two sides and an angle that are congruent. So that means I'm going to have, let's say, this side, this side, this side, and this side. Remember when we talked about included angle? Well, that's going to be this angle here on both of them. So this means I have to have two sides and an included angle are congruent. Okay, so that tells me, first of all, keep in mind that the angle is between the sides. So if I think about it in terms of these two, remember, numbers are very important. So triangle XYZ, we have to write it in terms of the letters, is congruent to. So if I have XY, which is this guy right here, well, this is also congruent to this guy. So UVW. All right. Okay, so if I look here, I have angle, side, angle. All right. So that's saying exactly like what it was saying before. I need to have an angle, the included side, and then the other angle. So the angle, the included side, and the other angle. All right. So I have two angles and the included side. So if I were to write that in terms of this, I would have JKL, so I'm going this way, all right? That's congruent to triangle MNP, and again, I'm going this way. So all of the angles, angle J is congruent to angle M, angle L is congruent to angle P, and so on. All right, AAS, or angle side, okay? So here we have two angles and a non-included side. So I have, let's say, angle, angle, side, angle, angle, side. So two angles and a non-included side. So if I were to write this, I could write it as GHJ going this way. remember these went this way, this one's going this way, that would be congruent to triangle XYZ, going this way. All right, now one thing to keep in mind is there are no bad words in geometry. So that means no angle side side or side side angle. We will never ever ever be able to use those as ways to prove two triangles are congruent. Okay, so now let's talk about some right triangles. Okay, so some right triangle information. All right, so here, this here and this here are legs. All right, so the legs make up the right angle. Okay, so if I put the two legs together, see how I get the right angle right there? That's what makes that. Now, on the other side, I have this guy right here. This is called the hypotenuse. Okay, and the hypotenuse is across from the right angle. So see, I went from the right angle and I can draw a line across. So it is the side across from the right angle. Okay, so those are important pieces of information to understand how we can use hypotenuse leg, or HL. Okay, so if hypotenuse in one leg is supposed to be congruent, so let's say that this leg here and this leg here, the hypotenuse and the hypotenuse. So if hypotenuse, remember the hypotenuse is across from the right angle, and one leg of a right triangle, that's a really important piece, are congruent to the hypotenuse and leg of another triangle. Has to be a right triangle, right? The two triangles are congruent. So if I were to add some letters here, I could do A, B, C, D, E, F, and I could say that triangle ABC is congruent to triangle DEF. Okay, and so for summary, these are our 5 methods. These are the 5 that you're going to want to know: side, 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 sine, angle, side, angle, side, angle, angle, side, and hypotenuse leg. Okay?